We use an aircraft grade stainless steel for these blowpipes. They have a low thermal conductivity. One end of that pipe can be extremely hot. The other end remains relatively cool to the touch. See there, he's got to get that up to a nice cherry red glow. The hot glass does not like to stick to cold steel, as you'll see as we use some of these room temperature steel tools throughout the process. And he's just reached down into this furnace. This furnace houses about 300 pounds of clear molten glass. It's kept at a temperature of 2,175 degrees Fahrenheit. That furnace is on 24 hours a day, 7 days a week, 365 days a year. It's been turned off once in the 6 years that this shop has been here. That has to do with its extreme thermal mass. It takes about 7 days for that furnace to come up to temperature. It takes another 7 for it to come back down to a room temperature if we were to do a repair. You can see it probably stopped rotating that pipe, that glass would drip right off of the end of it. You also note that bright orange glow coming off that glass. That glass is not orange, it's very optically clear. That orange glow that you're seeing right now is its own ultraviolet light it's producing. That's due to its extreme temperature. Well, he's got this small gatherer outside of the furnace here. He's allowing that to cool down. He's keeping it on center, rolling it back and forth as that cools, it stiffens. That's important because he's going to get one more layer of glass onto there, and he wants to make sure that that first one will support it. Much like dipping a candle, can't get all of the material we need in just one gather.
Sand, right? I mean, basically, it's just sand, right?
Glass?
Yeah, it's a mixture.
Alright, Paulie Mayville's going to come over and use something called a pulverized frit. This is one of the ways that we color the glass here in the hot shop. And you see this is a bag of frit. It's basically a pulverized glass that's had different metals or oxides added to it. As they add different metals or oxides to the glass, it colors it. In addition to titanium will turn that glass white. In addition of gold will give a whole range of rubies or reds. Cobalt oxide will give you a nice bright blue. Copper oxide, a series of greens, so on and so forth. There's companies out there that add these different metals to the molten glass, and they extrude it, pulverize it into different mesh sizes, and mail it to us. You can see how that pulverized glass sticks right to the outside of that hot gather. Paulie's using the heat inside of our reheater here. Well, he's got that nice and hot. He's going to bring it over and drop it down into that optical mold. Optical mold is a cast aluminum mold that imparts a series of peaks and valleys onto that ball of glass. He's not going to keep the third dimension that's created. He's going to get rid of that. But before he does, he's going to twist that up by turning it faster than he allows it to roll across the bench. This results in a corkscrewing of that pattern. The table he's using there is called a Marver table. It's an old Italian word for marble. Those tables used to be made of. Now we use a 1/2-inch steel sheet. Really easier for us to maintain And though the material of that table has changed, the name still remains the same. Old Italian word for marble. There's a lot of wonderful Italian terminology in here. We have all kinds of fun tools like taglios or chovis or pastorellis. So you get to learn a little bit of Italian as you learn to blow glass, which is interesting. You can see now that that surface has melted to where it's totally smooth again. There's no indentations anymore. You can see those color bands and how that color is split up. As that glass went into that mold, it created dense areas of color and thin areas of color, and it's resulted in little color bands. It's going to work now to initiate the bubble into this piece. There is no bubble inside there. It's solid glass. Got it nice and hot, put some pressure in there. You can just barely see it as it filled out that entire ball of glass. It's now hollow form. It's important to get that bubble started on early on in the process, because later, when we've accumulated all of the glass that we'll need to create this piece, it would be very difficult to get all that hot enough to initiate that bubble in the center. So, really important to do them early on. Something we call a starter bubble. Basically a placeholder for the interior of the vessel. Now you need some more material on here. The color pattern is finished for the most part. You need some more material on here, but before he goes back into the furnace, he's got to let that come down in temperature. He's going to know that he's down to a safe temperature by the movement of the glass if it stops swaying as he stops the pipe. He's also going to look for that bright orange glow to turn to a dull red glow. These will indicate to Paulie that he's right around 1,000 degrees, which is relatively cool in the terms of glass blowing. I'll also tell him that that glass is set up and it's nice and stiff and will support that next gather. If you went in too early and that ball of glass was too soft, you could potentially collapse the bubble as the weight of the surrounding melt surrounds it. Or worst case scenario, you could end up stripping that bubble off entirely, leaving it in the furnace, which then all that color would contaminate our clear that we keep in the furnace. By only keeping clear in the furnace, it allows us to work with the entire color spectrum as we color it outside of the furnace. You see he's down in the melt there, turning through it. He's come level, he's above the melt, allowing some of that glass to strip off inside of the furnace. He's got a substantial amount more glass into that rod. I'm going to come to this pipe cooler. It's going to splash a little room temperature water onto that rod. That'll bring that back down to a temperature he can comfortably handle with his bare hand. Well, he's going to take that over right away to his wooden block. See, this wooden block's made of a dense fruitwood tree. We use the fruitwood trees because they have little to no sap in them. You can see how that gives them a nice even distribution of that fresh material. Now this wooden block has spent its entire life submerged in water, which has allowed it to soak up as much water as it physically can. This results in a little steaming phenomenon known as the Leighton frost effect, and where upon introducing that 2,000 degree ball of glass into that wooden block, it immediately sucks the moisture out of the grain structure in the form of a layer of pressurized steam that ball of glass rides on, and it doesn't actually come in contact with that wood. This is also a very interesting wooden tool you wouldn't expect to find in here. It's about 11 pages of the Tampa Bay Times, then folded over and over onto itself until we have about 90 layers of that material. And allow that to soak in a pail overnight. Works on that same steaming principle as the wooden block. Paulie again is going to build up the heat in this vessel in anticipation of using one more of the optical molds. This piece of equipment over here is traditionally referred to as a glory hole. It reaches temperatures in excess of 2,500 degrees Fahrenheit. It's made of a castable refractory that'll take temperature on to about 2,300 degrees, and then it begins to emit that 2,300 degree temperature. So it's a very even atmosphere of temperature in there. Just gonna bring that out and literally drip it down into that optical mold. Once he's confident he's down in the bottom of that mold, he's gonna impart some air into that bubble. That's gonna push that glass out into the recesses of that optical mold. It's gonna result in a series of peaks and valleys. As the light travels through those peaks, it'll be distorted. That's how it got its name, the optical mold. Gonna tamp the front of that a little bit, preventing that bubble blowing out of the bottom of it. It's gonna impart a little bit of air. We always like to preheat our tools so it's not taking any temperature out of the glass. We also like to lubricate them using beeswax. You can see on the corner of the table there. He's just imparted what we call a jack line onto this vessel. Jack line is a compression made right at the end of the blowpipe. It'll later receive a droplet of water. That droplet of water will create a stress fracture. And stress fracture will follow the path of least resistance, which will be that jack line. It'll provide a clean, easy breakaway from the blowpipe. He's going to get a nice even heat on that vessel. On doing so, he's going to come out, get a nice full final expansion of that bubble. Always ask for something called a drop foot. We call it a drop foot because we're going to bring it over and literally drop it onto the table. Forward, down, back to you, down, back to you. Help him get that as center as possible. I'm just going to head over to the reheater to replace any of the heat that's been lost from that drop foot sitting on the room temperature table. Taking out a tremendous amount out of the bottom of that patty of glass, but the top side of that patty remains very molten. So it's important to come over and even those temperatures out before sitting down to the bench and starting to shape that foot up. We sit down to the bench here. He's use this wooden paddle to keep the bottom nice and flat, as he uses that stainless steel paddle called a tagliole. A tagliole setting a decorative bevel on the top side of the foot. Now shake that foot up. Oh, he's gone ahead and requested something called the punty. Punty or the punteel. This would be a solid rod with a single gather glass on the end of it. Bring Polly, that punty, he's going to take control of it and touch it down right to the center of the bottom of that vessel. You use that steel tagliole to take a little temperature out of that punty, stiffening it by cooling it. Now I'm going to start to introduce some water into that jackline area. It's going to create that stress fracture we were talking about earlier. A light tap of the tool. We got a clean, even breakaway from the blowpipe. A successful transfer onto the punty. You got it. Are all 6 of those mandarin in there? Yeah. Okay. So the other way we apply color to these vessels is something called color bar, which is basically that same colored glass, but it hasn't been pulverized into a frit. It's remained in a bar form. So Polly has a couple of these contrasting colors laid up in a hot box over there. He's asked me to grab one of them, shape it into something we call a lip wrap.